Okay, so moving on to more tangent line properties. So, two more things you need to know about tangent lines. First thing is that if two segments from the same external point are tangent to the circle, then they're congruent. So you're talking about these segments here. They're coming from the same external point, which is B. B is the external point. And these two segments are they're branching out from B. And since they're tangent to the circle, then they're congruent to each other. So this length is exactly the same as this length. AB is congruent to CB. Okay. Next property is that if a polygon is circumscribed around a circle, then all sides are tangent. Okay. So we have this triangle that is circumscribed around the circle. And so these sides of the polygon are tangent lines. So AC is a tangent line, AB is a tangent line, and BC is also tangent to the circle. Okay? And so with those lines being tangent to the circle, we know that if there was a radius drawn, that's going to create a 90-degree angle. Radius drawn here, it would create a 90-degree angle. Radius drawn going to this tangent line, that would create a 90-degree angle as well. Another thing is that polygon has external points. External points from the circle. So when I'm looking at this external point B, I could say that these two lines are congruent to each other. So now DB is congruent to BE. If I look at this external point, then these two lines are congruent, right? So now AD is congruent to AF. And then if I look at this external point, I can see that these lines will be congruent. So CF is congruent to CE. Okay. With those two new properties that we've learned, we're gonna solve these problems. So we read directions. It says find each value or measure. Assume that the segments that appear to be tangent are tangent. Okay. So it looks here that AB is tangent to the circle as well as CB is tangent to the circle. And since they're coming from that same external point B, that would mean that they are congruent to each other. So you should be saying that 8x minus 19 is equal to 5x plus 23. And then, of course, you would finish the algebra there, adding 19 to both sides. And I'm just going to do the algebra just for this problem. Like I said, unless it looks different. 23 and 19 should be giving you 42. Subtracting that 5x, we get that 3x is equal to 42. Dividing by 3, x is 14. Next, find SV. Well, again, we are to assume that the lines that look tangent are tangent. So SU and ST would be congruent to each other since they are coming from that same external point S. So again, this is another situation where you would set up that 10x minus 41 is equal to 4x plus 7. You would need to find SV here. And SV looks to be the hypotenuse, and that's because I see the radius here. And of course, the radius and the tangent line, as we learned earlier, would create 90-degree angle. So this is definitely the hypotenuse that we're supposed to be looking for here. I didn't mean to make that line because I'm not trying to say that they're congruent. I'm just literally saying that this is the hypotenuse. Okay. So I am going to finish this problem because we do have to plug it back in and then find the hypotenuse afterwards. So you're going to do the algebra on your own, but you should get that x is equal to 8. And with x being equal to 8, you plug it back into ST. So ST would equal 10 times 8 minus 41. So that's going to give you 39. Let me just plug this in. Okay, so now that you have ST is 39, you are also given that, so this gave you 39. You can kind of cross that out. And with that being 39, and then you were also given the 17 here. So you want to find the hypotenuse, and of course you would do that by using Pythagorean theorem since it's a right triangle. So you're going to do 17 squared plus 39 squared equals c squared. And that's going to give you that c squared is 810. 17 squared plus 39 squared is 810. Square rooting both sides, you should get that the c value is 42.5. I'm just going to move that up because it's kind of like we're squeezing it in there. So there you go. So the c value is 42.5. And of course, c pertains to the hypotenuse that we were looking for earlier, which was SV. So we found that SV is 42.5. Okay, next even number would be 14. Find the perimeter of quadrilateral PQRS. Well, first, in order to find perimeter, we know that perimeter means to add up all sides. Okay. So, do we have all sides? Like, we need to make sure we have that first. Looks like we don't have this entire side and we don't have this entire side. But we do have, this side is 37.5 and this side is 52.5. So we need to finish these sides, okay? So when I zoom in here, I can kind of pick things apart that I know. I know that any segment coming from the same external point would be congruent to each other. So these are congruent, and these are congruent. Okay? So, with that being said, I'm going to start by what I kind of see here is finding this piece. So if the entire side here is 37.5 and I only need this piece, I'm just going to subtract this piece from the 37.5, which is the entire thing. So again, in order to find this, I'm going to subtract this side from the entire picture, because if I have the whole thing and I just take this part away, what am I left with? That. Okay? And of course, we said that this is 23 because it's congruent to the other side. So this little nuzzle right here is going to be 37.5 minus 23. And that's going to equal 14.5. So now this is 14.5 as well. And it looks like I've completed this side here. So now 14.5 and 27.1 would give me 14.5 plus 27.1 equals 41.6. All right, so we successfully have three sides, 1, 2, and 3. We just need the last side over here, okay? And over here, it looks like the only thing we're given is that, if I zoom in, that these two are congruent, knowing that they come from S because of what we marked earlier. So for this little slither here, I am going to subtract this piece from the entire side. So something we did on the other side, right? So again, if I take the whole line and I just subtract this part of it, then I'm left with that. So this here is going to be 52.5 minus that piece over there was 27.1. And that tells me that this is 25.4. Add that with the 23. Again, that's 25.4 because these are congruent. So I said 52.5 minus 27.1 is equal to 25.4. And since these two are congruent, then this is 25.4. Okay? I don't know if I clarified that enough. So 25.4 plus 23 equals 48.4. So this side over here is 48.4. And now we have all four sides. So the last thing we're going to do is we're going to do 37.5 plus 41.6 plus 52.5 plus 48.4, and we get 180 is our perimeter. All right, that is the end of